Hey everyone, all around us, things are growing. Our savings accounts, the spread of ideas online, you name it. But here's the thing, they don't all grow in the same way. So today, we're going to dive into the two fundamental patterns of growth that, believe it or not, kind of run the world.
Just think about it for a second. Is growth like climbing a staircase, where you take one equal, predictable step at a time? Or is it more like a tiny snowball rolling downhill, getting bigger and faster and bigger and faster with every single turn? That's really the core question we're going to unpack today.
So take a look at this. We can see these two big ideas in their purest form. Over on the left, you've got this steady, predictable climb. We're just adding 3 each time, but on the right, we're multiplying by 3. It starts off slow, but you can already feel how quickly it's about to take off, right? These are the two main characters in our story.
Okay, so here's our game plan. We'll start by properly meeting our 2 types of patterns. Then we get to the really fun part, using them to predict the future. And finally, we'll see how to add it all up. Nice and simple. Let's jump right in.
So our first character is the arithmetic progression. I want you to think of this as the reliable, consistent pattern. It's like getting the exact same pay raise every single year. It's all about that steady growth that comes from simple addition.
The key thing to remember here is that in an arithmetic progression, or AP for short, you are always adding the exact same amount to get to the next number. That amount, whether it's big or small, positive or negative, has a special name, the common difference, and we just call it D.
And you can see just how simple this is. To build any AP you could possibly imagine, you only need 2 things. First, a place to start, we call that A, and second, the size of your step, our common difference, D. And that's it. With just those 2 little pieces of information, you can build an entire infinite series.
Okay, let's make this real with an example. So our series starts at 26. That's our A. Now how do we get from 26 to 29? Well, we add 3. How about from 29 to 32? We add 3 again. It's constant. So our common difference, our D, is 3. This is your classic, steady, ascending AP.
But hang on. What happens if that D value is negative? Well, you get a steady decline instead of growth. In this series, we start at 9, and then we add -2 each time, which, is really just subtraction. So you get 9, then 7, then 5, then 3. It's just as predictable, but it's headed in the other direction.
All right, it is time to meet our second and way more dramatic character, the geometric progression. Look, if AP is that steady pay raise, this is the magic of compound interest. This is where things get really explosive, because we're leaving addition behind and jumping straight into multiplication.
So, instead of a common difference, a geometric progression, or GP, has a common ratio. All this means is you are always multiplying by the exact same number to get the next term in the sequence. And we call that multiplier the common ratio, represented by the letter R.
And hey, just like our AP, a GP only needs 2 key ingredients. You still need a starting point, our A, but instead of adding a step D, you need a number to multiply by, our common ratio R. Get those 2, and you've unlocked the whole pattern.
Let's see this thing in action. We start with A equals 7. To get the next term, we multiply by 2. So 7 becomes 14. Then we do it again. 14 times 2 is 28. Then 28 times 2 is 56. You can already feel how this doubling effect makes the numbers grow way, way faster than our steady AP.
Now this is cool. Geometric progressions have a really interesting trick up their sleeve. If that common ratio R is a negative number, the series will actually flip-flop between positive and negative values. So here, we're multiplying by -1/5 each time, which creates this fascinating, alternating back-and-forth pattern.
Okay, so we get the patterns. But what good is knowing a pattern if you can't use it to predict what's coming next? That, my friends, is where formulas come in. I want you to think of them as little time machines for numbers. Seriously, imagine you have a series, and I ask you, hey, what's the 50th number in this sequence? Are you really going to sit there with a calculator and crunch the numbers 49 times? No way. There has to be a better way. And of course, there is.
And here they are. These 2 formulas are basically crystal balls for our number sequences. And notice they use the exact same ingredients we already talked about, A and D for the AP and A and R for the GP. All you have to do is plug in n, which is just the number of the term you want, and the formula just spits out the answer.
Okay, let's try one out.
We want to find the fifth term of an AP that starts at -13 and adds 6 each time. So we just plug those numbers into our formula. A is -13, N is 5, and D is 6. You do a little bit of quick math, and boom, you get 11. If you wrote it out the long way, you'd get the exact same thing. The shortcut works.
Now, let's use the GP formula and really see that explosive growth we were talking about. For the series that starts at 11 and multiplies by 3, what's the ninth term going to be? We plug in the values. A is 11, R is 3, N is 9. And you see that little exponent up there, the N-1? That is where all the magic happens. The result? A whopping 72,171 in just 9 steps.
So knowing the value of one specific term is super useful. But sometimes what you really need to know is the total. Like, what's the sum of the first 20 terms, all added together? And again, we do not want to add them all up one by one. We need another shortcut. You know, this isn't just abstract math. Think about a real-world problem like this one. To figure out things like loan payments or savings plans or total profits over time, you have to be able to calculate the sum of a series. This is where these patterns get really, really practical.
And just like before, we have this beautiful pair of formulas to do all the heavy lifting for us. One for the AP, one for the GP. You just tell them the starting point, the common difference or ratio, and how many terms you want to add up, and they'll give you the grand total instantly. It's awesome.
Let's see it work for an arithmetic progression. So we'll take that series that starts at 12 and adds 3 each time. What's the sum of the first 10 terms? We just run it through the formula, and the total is 255. Simple, clean, and so much faster than doing it by hand. Okay, now look at what happens with a geometric progression. This series starts at 5 and just doubles each time. The sum of just the first 9 terms is already 2,555. That is 10 times larger than the AP's sum, and we even used one less term. This really shows you the incredible power of that multiplicative growth.
So, let's put it all together in a final showdown. The arithmetic progression, its engine is addition. Its growth is linear and steady, just like climbing a set of stairs. Then you have the geometric progression. Its engine is multiplication. Its growth is exponential and explosive, just like that snowball rolling downhill. Two simple patterns that describe two profoundly different ways our world can change. And that just leaves one last question for you. Now that you can see the patterns, where are you going to spot them next?